Alright guys, quick video here on parallel and perpendicular lines. This is something we spend a little bit of time on in algebra, and then next year in geometry you have to become more of an expert with these things. This year we're just going to focus on a couple of aspects of parallel and perpendicular lines. So what the heck do these words mean? Okay, so here's what I'm going to do. I'm going to draw a picture. If I have two lines and they look like this, both lines are going in the same direction, and if I had to guess, I'd probably say they're never going to touch each other. They're never going to cross. They're going to both keep going up, 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 but never actually cross each other. And when that happens, we call them parallel lines. And in algebra and geometry, sometimes you learn these little symbols. They look like these little racing track arrows. But to denote these two lines as parallel, you draw these little triangles. And it just means that both of these lines are never going to cross each other. So let's call this line A and this line B. I can say A and B are parallel. So I'm going to write that over here. A is parallel to B. And I'll draw these two little lines. These stand for parallel. A is parallel to B. If I was to draw a line that cuts through these, like this, definitely not a parallel line. I'm going to call this C. C is not parallel. Instead, it's called a perpendicular line, but that's only if it cuts through and makes this perfect little, right here, a 90-degree angle. If it makes a perfect 90-degree angle when it cuts through, then it's called a perpendicular line. And sometimes when we show a 90-degree angle, what we do in geometry is we draw a little box in the corner, and that stands for 90 degrees. And we would say that C is perpendicular to both of these other lines. So like line A and line C, they cut through each other right here. So A is perpendicular to C. And here's how I'm going to write that. A is perpendicular to C. This little symbol looks like an upside down T with a 90-degree angle in the corner. It stands for perpendicular. They cross each other at a 90-degree angle. What I'm going to do is I'm going to actually split these two up. I'm going to draw a line and split these down the middle and build a little table out of all this information. This is going to be my parallel side. And I'm going to write versus perpendicular. Parallel versus perpendicular. And we're going to talk about some of the similarities and some of the differences. Make a little chart out of this. So parallel means that the lines never cross. That's an important fact. They never cross. But perpendicular means they cross and make a 90-degree angle. So the lines cross at a 90-degree angle. At a 90-degree, it's a little degree mark, angle. So for parallel, the lines never cross, and for perpendicular, the lines cross at a 90-degree angle. That's an important fact. Here's another important fact. We have been studying lines, and we've been studying slope. So if you look at the parallel lines up here, A and B, they're both growing up. They're both going up with a slope that looks the same steepness. So parallel lines have the same slope. Same slope. Perpendicular lines definitely do not have the same slope. Look at how one line's going up and one line's going down. They have opposite slopes. Opposite slopes. And that's the major difference between them. Parallel lines have the same slope. Perpendicular have opposite slopes. So I'm going to scoot this up, and we're going to make up some examples here. And we're going to write over here, example. And what I'm going to do is I'm going to draw a graph. So let's draw a little XY axis. And we'll get this all set up, ready to go. And let's do the same thing on the other side, on the perpendicular side. Let's do a matching XY axis. So we're going to be doing a little bit of graph in here. And again, pause the video if I go fast so that you can catch up. But let's try and do this. What I'm going to do is on this first graph, I'm going to graph the equation y equals 2x minus 1. And that's an easy graph. By now, you're really good at lines. So we know the graph starts at -1, which is right here. And we know that the graph, it has a slope of 2. So that means it goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So if I connected these points, took a ruler, this is my line. This is y equals 2x minus 1. There we go. And I can write, this is y equals 2x minus 1 down at the bottom. Okay, well, I want to draw a line that is parallel. So what do we know about parallel lines? They never cross and they have the same slope. So this thing has a slope of 2. So my parallel line has to have the same slope. But it's probably not going to start at the same spot. It's going to start somewhere else at a different y-intercept. So I'm going to go somewhere else on my graph. I go up here to 1. I go to 2, 3, 4, 5. I could go down below here to -2, -3, -4. It doesn't really matter. It doesn't tell me where. So how about we start it at, I don't know, let's start at 3 as our starting point. So a brand new y-intercept, start at 3. We're still going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm not going to be able to do lots of them. I'm going to be off the graph, but a couple of dots and I can draw a line. So here is my parallel line. Look, they're never going to cross. They're going side by side. They're both going up 2 over 1, up 2 over 1. The rule for this new line, the equation, is going to be y equals 2x. But now instead of a -1, we started at 3, so plus 3. And there's my rule. 2 very nice parallel lines. Perpendicular lines are different. They're opposites. So let's graph y equals 1/3 x plus 1. Let's put that on our other graph. 1/3 x plus 1. So that means we have a rule that starts at plus 1. So on the y-axis, I start here at 1. And then my slope is 1/3. So it's a rule that's going up 1 over 3. Up 1 over 3. Up 1 over 3. So it's going to look like this. Up 1 over 3. Well, perpendicular means it's the opposite. It's going to come down and cross through it. So I need opposite slope. Opposite slope means it's going to have a different sign. This was a positive slope. Perpendicular, it's going to be negative. It's going to be the opposite. And 1 over 3, opposite would be down 3 over 1. So we're actually going to flip the fraction over. The new slope is now going to be -3 over 1. Down 3 over 1. Total opposite, -3 over 1. So we can start the line. We could start at 1 if you want. We could start up here at 5 or 6 or 7. It doesn't matter where we start, as long as we have the opposite slope. So why don't we start at 1? We'll keep the same starting point. But now I'm going to count down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And I'm going to take these points and connect them with a line. And there is my perpendicular line. Right here makes a perfect 90-degree angle if I measured it. So crosses right through each other. If I had to write a rule for this line, it would be y equals -3 over 1, but I'll just write -3x, plus I still started it at 1. That would be my rule. But it has completely opposite slope. This thing was 1/3, so this thing is -3. Now you don't have to do graphing for all the parallel and perpendicular problems. Here's how you could do it without graphing. First example. Let's say I had the rule y equals 4x plus 5. And I said, can you write me an equation that is parallel? And can you write me one that is perpendicular? You should be able to do this. Parallel and perpendicular all have to do with the slope. So what is the slope in this problem? Well, we have a slope of 4. So what do we know about parallel lines? They have the same slope. Which means if I was to write a new equation, it's still going to have a slope of 4. It's still going to be y equals 4x. It's just, instead of plus 5, you can start it somewhere else. You can do a plus 2, plus 100, plus 1.734. Doesn't even matter. You could do minus 5, minus 3, plus negative 2. Honestly, pick a number, like I'm going to do plus 2. Any y-intercept will do, as long as you have the same slope. Perpendicular has opposite slope. So opposite means we're going to have to flip it around. If this is a slope of 4, that's really 4 over 1. Up 4 over 1 on the graph. So what is the opposite of this? Negative 1 over 4. Negative and flipped it upside down. So my perpendicular rule is going to be y equals negative 1/4 x plus whatever starting point you want. You can keep it the same as the plus 5. You can make it a plus 3, a plus 7. Doesn't matter. But there's my opposite slope. There's my rule. Y equals negative 1/4 x plus 3. So now you try one. Pause the video and see if you can solve this problem. Take the rule y equals negative 2/3 x plus 3 and write an equation that is parallel and write an equation that is perpendicular. So try it. Pause the video, do it on your own, and see what you get for an answer. Okay, so here's what I'm getting. Parallel lines mean they have the same slope. So it's negative 2 over 3, which means parallel is going to be exactly the same. Negative 2 over 3x. Your plus whatever, your y-intercept, you pick. You might have done 5 or 10, or you might have picked 100 or 3 or 7, or doesn't matter. I guess you didn't pick 3. It has to be something different. Then for perpendicular, it's going to be the opposite. So instead of y equals negative 2 over 3, it's going to be positive 3 over 2. Positive 3 over 2x. Plus whatever you feel like. Plus 1. Plus 12. Plus 100. I don't care. Anything. Plus something. That'll be my perpendicular rule. So hopefully that kind of helps. Parallel has the same slope. Perpendicular has the opposite slope.